Okay, welcome back everyone. This is the final video of the year. And so in this, we're going to do a quick example problem of how to ray trace with lenses and calculate a few things. So this is number 77 on page 758. And so what we're given in this case is we have a situation where there's a concave lens with a focal length of -45 centimeters, and an object is placed 30 centimeters in front of it. And so what we want to do is to calculate and then ray trace for the image. So first we'll do the math. So 1 over f equals 1 over do plus 1 over di, or 1 over -45 is 1 over 30 plus 1 over di. Common denominator is 90. And in this case, we are going to have -2/90 minus 3/90, so -5/90 is 1 over di, or di is -18 centimeters. Now, one thing that we didn't get to talk about in the previous video is that having a negative image distance for a lens means that the image is on the same side. It's on the same side of the lens as the object. And this makes sense because lenses don't really work like that. Lenses pass light through and form real images on the opposite side. Okay, so let's draw in a concave lens here. My drawing skills are not that great. And let's put tick marks every 15 centimeters or so. Close enough. And let's put our object at 30 centimeters. So our focus is going to be here and another one over here. Okay, and let's ray trace. So once again, we have the ray that goes in parallel, and that appears to have come from, so this is going to be kind of weird, appears to have come from that focus. Okay, so we draw this out and we kind of try to line that up slightly. Okay, and the second ray is the one that tries to go through the other focus. So this is different from what we've done with mirrors. And then that ray ends up going parallel. And so those are the two rays that we want to trace backwards. And of course, okay. Alright, and we get an image that's somewhere around there. That's looking more like 22 than 18, but you definitely get the right idea. Okay, so that's part A. Then part B is just strict computation. Now we're substituting a convex lens, a focal length 57 centimeters, and we want to calculate the image location. So again, 1 over f is 1 over do plus 1 over di, and I'm just going to set this one up, 1 over 30 plus 1 over di, and what we get from this is that di is about -63.3 centimeters. Okay? Now, a couple words about this. I'm not going to do a very careful ray diagram, but whoa, let's try that again. Okay, so if we're talking about a convex lens, and if we have a focus that's basically 60 centimeters, and if we have an object, so that's f, which is put at at basically half of that, we already know how this is going to end. Okay, the one that goes in parallel goes through the focus, and the one that came from the focus comes out parallel. Now this is a convex lens, so we do things the opposite of a concave, but we still can trace these back, and if I had been more careful about my diagram, I would have had an image over here at about 63.3 centimeters. So showing once again how we locate images. Okay, well that's it. I hope that these videos have been useful to you. Feel free to let me know how they can be improved, and I'll catch you next time.